Okay, Gauri, I will start.
Okay, sir.
So introduce yourself.
Sir, my name is Gauri. I am coming from Kollam district in Kerala. I have completed post-graduation in physics from NIT Trichy. Currently, I am preparing for physics-based job exams. Um, that's all.
Okay. So which quality or the which thing attract you towards this geophysics field?
The profile of the job attracted me the most. Um, Actually, I like field service, and thereby I can travel to the different parts of the part of India. That's what the main thing interests me.
So do you know the job profile of geophysicist in GSI?
Okay, as a geophysicist, I believe that my purpose is to contribute to the exploration field and to apply the physics for the exploration of minerals and metals.
Okay. Okay. Tell me how many type of minerals that you know.
Minerals. Sorry, I don't know the classification of minerals.
Can you name any one or two minerals which are essential for human body?
Okay, we can say mineral elements as potassium, iron, sodium, etc. For within our body. Mineral is generally a compound formed of elements and uh, other reaction happened within it. So I can say mineral elements such as sodium, potassium are important in our body.
Okay. 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 Good. So also, what is the difference between a rock and a ore body?
Our body. Uh, okay, rock is actually composition of different minerals or ores. Ores are um, uh, is important in a way that uh, it is meant for it decides whether that mineral within the rock is good for exploration or it is uh, economically viable. That part of the minerals in the rock is called ores.
Okay, good. So, with the electrical use of electric method, electric survey, which type of minerals or ore body you can find, explore?
Actually, in electrical methods, we used to find out the variation of resistivity within the subsurface. So we can um, either uh, discover very low resistivity material or high resistivity material within the subsurface. But with an exploration aim, we mostly concentrate on conductive minerals.
Okay. Do you know any other electrical properties of rock which are important in the electric method?
Um, we are also using the dielectric property in case of electromagnetic technique um, uh, to differentiate material.
Okay. So, according to you, which is the most important property for the exploration of minerals and rocks?
Uh, the resistivity or conductivity is most widely used in most of the electric methods.
What is
Yes.
conductivity? Define the conductivity.
Um, it is an uh, inherent property of the material, um, which which indicates the ability for the charge to move or the conduction of current. Uh,
Okay, so which type of charge is uh, responsible for the flow of current?
Both electrons and protons are responsible for the conduction in case of a metal, whereas
Okay,
in an okay.
both are you sure? Proton and electron both are responsible in metals.
Actually, we are defining the flow of current with by the direction of flow of protons.
Okay, in minerals, conductivity is due to electron or proton. Sorry,
It's
in
the to
conductors.
the presence of free electrons.
Okay, okay, okay. So what is the unit of conductivity?
Conductivity is measured in ohm inverse, meter inverse, or
Okay,
it can Siemens per meter.
okay. Any CGS unit?
Uh, Sorry, I don't recall.
Okay. What is the difference between resistance and conductance?
Um, they are inverse of each other, uh, and one represent the opposition to the flow of current, and other indicates the ability to flow.
Okay. So how many type of conduction do you know with respect to Earth?
Okay, actually, sir, there is three types of conductions. First one is electronic conduction, second one is dielectric conduction, and third one is electrolytic conduction.
Okay. So which one is responsible for the flow of current uh, uh, um, through the ground, means Earth surface?
Actually, all three have influence um, in the flow of current. If there is electrolyte within the pores of of a medium, this will contribute. It will be contributed by electrolytic conduction. When there is a presence of insulator, there is a small contribution due to the uh, dielectric conduction. And in case of presence of conducting bodies, it will be due to the electronic conduction.
Okay. So Earth is a conductor, semiconductor, dielectric, what? What is Earth?
Earth is generally um, mentioned as a poor conductor with an average resist, conductivity of 10 raised to minus 2 um, minus meter mass.
Okay. Comes to the self potential. What are the natural potential?
What are the
Natural potential in the ST method.
you mean what are the causes of this occurrence of cell potential, right?
Mhm. Yes, yes.
Okay. Um, the self potential can occur within the earth, either due to mechanical origin, or it can be due to electrochemical origin, or otherwise. The most important one is the mineralization potential. These are the three potential which are responsible to give self potential. The mechanical potential is contributed due to the flow of current, um, uh, uh, flow of electrolyte within the pores, and this is determined by the pressure variation, concentration variation, etc. And other and when coming to electrolytic electrochemical potential, these are contributed due to the difference in the uh, concentration, mobility, and also the temperature effects. And when coming to mineralization potential, it is due to the redox reaction happening at the two surface um, with water table as the boundary.
Okay, so what is the order of this mineralization potential?
Uh, I think it is 100 millivolt, order of 100 millivolt.
So which one is important for the electric survey?
Electric survey, um, uh, we can't say which method is good for electric survey. Within the electric survey, we are um, uh, in trying to determine different factors. For example, if we are trying to um, search for a massive ore body, we will be searching for the potential due to mineralization, and whether we are going to analyze the geothermal effect, we will be searching for the potential due to the electrochemical potentials, like that. And if we are analyzing the flow of water, then we will be searching for the streaming potential or mechanical potential.
So what are the two field methods in the SP method?
Okay, SP methods, generally we need a potential electrode to measure the cell potential within the subsurface. We use two methods. First one is gradient method, and other one is total field method. Uh, do I need to explain that?
Okay, so have you heard about the leapfrog technique?
Yes, sir.
What is that?
Actually, in gradient method, um, we are using a the pair of electrodes which have a fixed separation, and we used to move this electrode along the profile line. But while we are doing this, there is a chance of increasing the uh, um, error due to the slight polarization effect due to the electrodes with the ground. So this in gradient method, this error will accumulate as we add the whole potential along the survey line. So in order to reduce this effect, we use the leapfrog method, where we will just flick between these electrodes so as to cancel this error due to polarization.
Okay. Okay. Any advantage and disadvantage of this gradient method?
Okay, in gradient method, um, this cumulative error is increasing, and we need to replace both the electrodes during the traverse through the profile. And whereas in total field method, our total error will be minimized, since we are using um, uh, we are only moving a single electrode, and here the difficulty is the need of a long cable, so so that we can cover a large area.
Okay, good. What is polarization?
Polarization is actually the separation of electric charges, and um, in general, polarization is the separation of electric charges.
So which quantity this cause the separation of charges? Why?
Okay, this can happen due to the presence of external field, um, uh, or due to the barriers present for the flow, this all can happen, cause the polarization within a material.
Okay. My last question. What is
Yes.
the advantage of the SP method over the IP method?
In SP method, we do not need a source, whereas in IP method, we need to apply an interrupted direct current. Mm, in SP method, we can only detect massive ore bodies, whereas in IP method, we will be focusing on disseminated charge ore bodies. Mm, and in both these methods, there is a difficulty that we can do the survey only with only by making a contact with this ground. That's all.
Thank you, Gauri. Pawan?
Thank you, sir.
Yes, yes. So, Gauri, we all of you know that कि UPSC combined geoscientist requirement for the geologist, geochemist, geophysicist, and hydrologist.
Yes,
It
sir.
is. So, what is the basic difference in related to job profiles in geologist and geophysicist?
Um, okay. In geophysicist will try to decide which exploration method we can employ. Uh, we can choose to detect to analyze a particular property, whereas a geologist can suggest the properties of this mineral or element which we are trying to explore, and also the further um, exploration after the detection of the presence of a particular mineral in the subsurface area.
Any other, if you know?
No, I don't know.
Okay. Gauri, you from physics background and geophysics background.
I'm from physics background.
So, do you think that GSI recommend for as a geophysicist? So, why we are eligible for a physics student to become a geophysicist?
And it's an area where uh, the knowledge we have gained so far about the different fields. First of all the exploration techniques using in GSI are based on physical methods or physics related field. So it's it's obvious that our knowledge will contribute to the exploration field.
Okay. And Gauri, you from physics backgrounds, you already tell that. So, tell me what is your strengths we can select you, and or what is your two weak point? Do you know? What is the strengths and what is the weak point?
Okay. I'm able to work in the field in a uh, stress field, um, and my problem or weakness maybe um, sorry, I cannot recall.
Okay. So, do you know, Gauri, the headquarter of GSI?
I think it is in Bangalore.
Are you sure?
Not 90%. I'm sure it's in Bangalore.
I think you from belongs to Karnataka.
No, no, I'm from Kerala.
Yeah. And any regions, any JSI, I think any branch of JSI which is situated in Kerala. Do you know?
I think there is three offices of GSI within Kerala, but I don't know the particular field they are working.
And which minerals are found in your areas?
Actually, sir, my area, especially I will say that Chavara in Kollam district is very famous for the presence of heavy mineral elements like illuminate, rutile, zircon, etc. And it is a heavy economic. It is giving a heavy economic resource to our country, and it is largely available along the coastal beaches extending from Chavara to Kayankulam district, Kayankulam in Kerala.
Okay. So, Gauri, can you tell me what is the use for this particular minerals which is you told you? Tell me.
Okay, actually, thorium, but which can be made into a fissile material, but currently in countries like India are not utilizing this method. We are generally focused on uranium as fission product, but there are countries like France which are making use of thorium to convert it into a fissile material and then further using it as a reactor fuel. So we are mainly exporting this to other countries, even as a raw material itself. We are not extracting the thorium in our country. We do not have that facility in our country. And when coming to other uh, monazite, rutile, etc. These are the compounds. These are the minerals from where we can extract titanium products. Titanium oxide is an important product which have many applications in the construction of aircraft bodies, since it have the similar properties of the steel and even with high heavy resistance to temperature and all those features.
Okay. So, can you use registry method to obtain the information minerals in your areas? Can you use?
Actually, it is not that electric method is not suitable in our area since it is appearing in the um, coastal beaches of Kerala. Uh,
So, which method, which is method is appropriate for in your areas?
uh, Mostly gravity method will be appropriate since these are heavy mineral elements.
Okay. So, Gauri, tell me what is the basic principle of resistivity method?
Okay, in resistivity method, we will be using Ohm's law generally. Um, yeah,
Okay. So, what is Ohm's law?
Sir, Ohm's law states that um, current within a electric circuit will be proportional to the potential difference applied within it.
So, Ohm's law valid for insulator, conductor, and dielectric. Both the case, Ohm's law is valid.
Uh, yes, I think.
And what is the dimension?
Sorry, sir, your voice is breaking.
Right now, it's okay.
Can you repeat the question, sir?
I repeat that. What is the unit of resistivity?
Unit of resistivity,
Yes.
ohm meter. Its unit is ohm meter.
Okay. And unit of conductivity.
It's inverse of resistivity. Actually, first question was you are asking about resistance or resistivity? Resistivity, right?
Yeah, okay. Forget all the question. I ask another question. So, Gauri, what is the disadvantage of resistivity method if you compare to the other method like a gravity, magnetic, something like
Disadvantage is that it's only possible as a land survey. Airborne surveys and marine surveys are less possible since we need to physically implant the electrode uh, to the ground.
any more if you know.
Um, Sorry, I know like about this.
And advantage.
And also, sir, one more thing, we need to choose among these electric methods appropriately for the different minerals. We, it's not a single method. We are utilizing different properties. So in one way a merit and also a demerit.
Okay. If we do survey in a field, so which method is you if you measure first? I give you example. One is resistive method. Second one is cell potential. Third one is induced polarization.
Uh, I will. Sorry, sir, I don't know.
Okay. And do you know how to measure cell potential in a field?
Um, yeah, actually, for the measurement of cell potential, we will use two potential electrodes such that they are mostly non-polarizable, um, and we will measure the voltage using a voltmeter, which have a high impedance, so that it can measure that minute variation in the potential.
Okay. So in field method we use two method. One is gradient method. Second one is the total field method. So which is most appropriate? What do you think?
I will for a large to cover a large extent of area. I will prefer gradient method.
And we know that in gradient method, cumulative error is very high in compared to.
Yeah, but
So what?
we will also need to consider about the cost of survey. So in a large area, it is preferable for me to go for gradient method. In a small region of survey, we can prefer total field method, I think.
Are you sure?
No, it's my opinion, sir.
Okay. So you mentioned that we use non-polarized electrode for obtaining the cell potential. Why we are use non-polarizing electrode?
If we are getting a polarization, that will also add to the potential we measure. So it is an error.
Okay. And why we are use high impedance voltmeter?
Uh, for getting that resolution of small potential difference that we need to measure beneath the surface.
Any other reason?
Sorry, sir, I don't know.
So which type of Ore body we obtain the negative anomaly of cell potential?
Um, in SP method, we will get obviously negative potential for the case where mineralization potential is occurring, and this will occur mostly for sulfide ores like pyrite, pyrite, even graphite.
Do you know any minerals which is have positive cell potential?
Um, I think quartz vein is creating positive anomaly.
Why we are obtain the positive or negative anomaly? Any specific reason?
It's why we are actually mineralization potential. Um, the upper top part of the ore body will create an negative potential, presence of immense negative charge. So it creates a negative potential for mineralization case. Um, and I don't know the case about this other very. And in other all cases, it can be either positive or negative, depending upon the situation.
So, okay. So, Gauri, what is the tell me what is the procedure for measuring the resistivity in the field? First, which we do first, and after that we collect data and something like that. What is the procedure?
Okay. In resistivity method, our first method is whether we need to decide whether we need to choose the area or not. We can do it by analyzing the recurrence map or other previous studies, and through that we can decide whether we need to do the survey. After that, once we have decided the region to analyze, we can use this um, different electrode configuration according to the need of our survey, whether we need vertical electrical sounding or we need lateral profiling or um, electric tomography, or which method we need. According to that, we will choose the appropriate electrode configuration, and after that we will measure the voltage. This voltage, we know the current we have applied. After that we will find the resistance, and further using the electrode configuration we will find the resistivity value, and we can compare the and in and further we need to apply some of the corrections accordingly, and further we will go for the interpretation. It can be done with direct or indirect method. um, and direct method we will use a already known model to analyze and correct the um, model by analyzing it with the theoretical analyzing the theoretical and the field values, and thus we will get a qualitative idea about the nature of the subsurface mineral we are searching for.
So we can precisely say that this type of body presents in the subsurface.
With the
But
qualitative, uh, we can know approximate resistivity variation. By that we can either um, choose or approximate the material that is probable in that area.
do you know what is the tomography?
Actually, I think it is the vertical variation within the surface, I think. It can be either 2D or 3D.
Are you sure?
Yeah, yeah.
Okay. And what is the resistivity range for groundwater?
Resistivity range for groundwater. So, Racer, I don't know.
Do you know which rocks have a more resistivity if we compare to the igneous, sedimentary, and metamorphic?
Igneous rocks have higher resistivity when compared to other three. Sedimentary have the least resistivity since it have a great amount of pore structures which can accommodate electrolytes so that it increases the conductivity.
If we compare to the oil and water, which one have more resistive?
Um, More resistive. I think oil have more resistivity.
Okay. Okay. Thank you, Gauri.
Thank you, sir.
Okay, thank you, Bhagavan. Agya, would you like to ask?
Is it only on electrical or EM also?
Only on electrical.
Uh, okay. Okay, Gauri. So one thing I wanted to ask, you asked yesterday, I did not get the answer. So what is one of the application of electrochemical type self potential?
Application. It's for the search of geothermal studies. It's used in the geothermal studies, groundwater studies, etc.
Can you explain this electrochemical self potential?
Uh, Actually, okay. It can be either due to diffusion potential, uh, or it can be due to Nernst potential. Diffusion potential, it is due to the variation in the mobility and the concentration of the respective mineral and their uh, um, respective minerals within the solution. And whereas when coming to Nernst potential, it is due to the potential difference between two electrodes that's implanted in a homogeneous solution due to the contact potential due to this electrode and the electrolyte.
Okay. What is over voltage and what is the application of over voltage in IP method?
Okay. In general, we are calling the uh, induced polarization uh, potential is as over voltage because uh, we are applying a fixed input to the ground. In compared to that voltage, we are getting an extra voltage. That's why we are calling it over potential. And this over potential is due to the two sorts of polarization happening within the subsurface. One is membrane polarization and other is electrode polarization.
Okay, why does the electrode polarization occur? What does it suggest? Presence of what?
It indicates the presence of disseminated minerals, which is blocking the pores within the subsurface.
Metallic minerals or non-metallic minerals?
Yeah, it's metallic minerals.
Okay, and what is the limitation of resistivity method?
Um, so the main disadvantage is this difficulty in the field survey due to the since we need to physically be present at the area where we are introducing the survey to have a physical contact with the surface.
Okay, can you explain the problem of suppression?
Suppression.
Yes, in resistivity survey.
Yes. Suppression. Uh,
There are
in,
two problems: problem of equivalence and problem of suppression.
I think the suppression Sir, I'm not sure. Can I guess?
Yes, yes.
Okay, so suppression. I think that there are certain areas um, which have a higher conductivity or high resistivities within the subsurface, but these we cannot identify these regions due to the presence of other elements above this region. So it is blocking the detection of the subsurface layer. Is
No,
it what?
actually, in problem of suppression, what happens in the type A or type Q type curve in the three-layer method?
Okay,
So,
okay.
can you tell the
Yeah,
uh,
I think
type?
due to the um, low thickness of a intermediate layer, we will uh, miss the presence of that intermediate layer. That's what is
Yes,
right.
in the particular case of type A and type Q. So, explain the type A or type Q type curves.
Okay, okay.
I mean,
In A types, the resistivity generally increases with the depth, and in Q type, it decreases with the depth.
yes,
So,
yes, it will not occur in the other types because when it is monotonously increasing or decreasing, then any layer can get suppressed because we cannot detect it from the curve pattern
okay,
if the
thank you.
layer is low thickness.
Okay, thank you for the information.
Okay, I am done. Thank you.
Thank you, sir.
Thank you, Agya. Amrit,
Ah, so Gauri,
Yes, sir.
uh, what do you understand by geophysical exploration?
So we are using different filter techniques to explore the subsurface of the.
We use different technique. What are those technique? Can you briefly summarize?
Uh, this involves different fields like electromagnetic. We will be using electromagnetic fields, electric currents, mm, seismic waves, acoustic waves. We will be using radiometric techniques to analyze the subsurface.
Okay, is it any? It should be at any random place, or there should be some particular hints where we should start any survey.
Um, uh, Randomly choosing a area for survey will not be economically viable. So we will need to have a initial um, initial data collection from the previous studies um, to initially start or locate the corresponding area to be surveyed and to choose which method will be appropriate.
Okay, so what do you measure in electrical method?
In electrical method, we will be focusing on the resistivity or conductivity of the layers of Earth on the nearby subsurface area.
So is there different layers beneath the Earth surface? How will you confirm it?
Uh, you mean the near surface layer differentiation or the general? Uh,
Yes, yes, I am just asking about different layers beneath the Earth's surface. Whether there are different layers or not, how will you understand this?
okay, if we are talking about resistivity method, it is actually have a in general have low um, penetration depth. So we will be able to analyze the near surface um, differentiation of the layers based on the resistivity.
Okay, so you,
Hello, Moto. Sorry, sir.
No, actually, some noise was there. You just mentioned about the uses of cell potential, particularly electrochemical. Can you briefly explain how electrochemical will be useful for geo?
Sorry, Kalpana.
Hello, did you get my question?
Yes, sir. Yes, sir. Um, I think in this in the case of electrochemical potential, we will have a variation of this its properties with the temperature. It has a temperature variation, so this will help us in geothermal studies. So
And
that's why we are using it in geothermal studies.
okay, and in case of groundwater, how will it be different?
And this temperature difference also influence the resistivity of the groundwater. Also, I think so. Actually, these two are mentioned together. So the
Okay, is mineralized potential also belongs from electrochemical or it is different?
uh, actually it is mentioned different since it is quite higher in magnitude when compared to this electrochemical potential. And this is occurring in case of sulfide metallic ores.
Okay, name some uses of SP and IP.
Um, so the main applications of SP is the detection of massive ore bodies, and in IP method it is for disseminated ore bodies. And both this method can be used for the detection of geothermal studies. And for and this SP method, we can use it for the detection of leakages from dams or uh, like that. And in archaeological surveys, also we use IP method to the cavity detection. And in both cases, we are using it to analyze the glacial studies, like to inspect a site where there is a chance of occurrence of permafrost or not.
What is permafrost?
It's the presence of an ice layer beneath the subsurface.
Okay. Do you know about pseudo section?
Yeah, it is the analysis technique used in IP method where we will be uh, plotting and further contouring the different parameters we measured from the IP method.
Okay. How electrical method is important in terms of other geophysical method? Briefly summarize.
Okay, in mineral, the electric method is most important in mineral exploration part. Uh, uh, and it is a major thing that is differentiating from other methods. Here we are measuring this electrical property. So and also this electrical method. You're asking about differentiate this method from other, right?
Yes, how it is of our
Okay.
advantage with respect to others.
Okay. Thus, need of the electrodes to be physically implanted within the ground is a demerit when compared to other methods where only ground survey is possible here. Um, and in electric method, we have different choices um, within it, whether we need to choose SP, IP, or resistive method, like so. That's also.
Okay. Okay, I am done.
Thank you. Sumana, would you like to ask something?
Yes, Gauri, can you please tell me which array should be useful, will be useful for detecting horizontal variations?
Which?
Array, electrode array.
Okay. Horizontal variation. For lateral profiling, we are using for near surface, we will be using Werner array, and for a deeper lateral profiling, we will be preferring dipole array. And
uh, Both Wiener array and dipole array are suitable for good lateral resolution. I mean, good horizontal resolution.
uh, yes,
Okay. Okay. Can you please tell me that in case of SP, what is the basic drawback of SP method?
mm, when compared to other electric methods, right?
Mm, Not
Or
compared to other electric methods. I mean, if you uh, I mean just the drawback of SP method, there is one phenomena that SP method cannot explain. Can you tell me that?
sorry, ma'am, I cannot recall, or I don't know.
No, no issue. Um, you have told that there are two types of polarization in IP, membrane polarization and electrode polarization, right?
Yeah, yes, ma'am.
Okay. And why membrane polarization is generated?
Thus, membrane polarization is occurring due to the presence of um, negatively charged clay elements within the pore surfaces, which will either constrict the pore size or either block the movement of the ions due to the presence of high amount of positive ions accumulating near these negatively charged surfaces.
Okay. Mm, Then can you please explain that? So, what type of polarization would be helpful to get disseminated minerals? Either it is membrane polarization or it is electrode polarization.
Uh, Electropolarization is the factor which are helping us in uh, analyzing the presence of disseminated ores.
Okay, good. Uh, Now tell me one thing that in case of Schlumberger array, okay,
Mm.
what should be your preferable potential electrode ratio? What should be the preferable ratio for current electrode separation to potential electrode separation?
The potential electrode separation will be 1/10 of the separation between the current electrode separation.
Is it 1/10 or minimum 1/5? At
Mm,
least we should keep them as 1/5, na?
Sorry, madam, I don't know.
Okay, it's okay. Uh, Acha, can you please tell me that in case of pole, what happens? We have to shift one current electrode and one potential electrode at infinity, right?
Yeah.
So what do you mean by infinity? Because practically there is no infinity. So how do you make it as infinity? What steps will you take to make it as infinity?
Actually, it can be. Sorry, ma'am, I don't have an idea about that.
Basically to make
Basically, it
basically
need
to
to
make
be
it
at
as
a greater.
infinite. Uh,
Sorry, ma'am. Sorry, ma'am. You can.
Basically to make it as infinity, what we have to do, we have to keep the current electrode and potential electrode at least 10 times um, distance of the electrode spacings. Okay,
Okay. Thank you.
that if we keep them at 10 times distance, then the current electrode or potential electrode will act as a single electrode.
Okay.
And can you please tell me the in case of graphite ore body, what combination should we use to detect graphite ore body? Combination, not a single method.
I think. Sorry, ma'am. I don't know. I think it depends upon the depth of investigation.
No,
No.
graphite is highly conductive, right?
Yeah.
So you may use both the for graphite ore you may use both SP and resistivity survey.
Oh, you mean this? Okay. Okay.
Okay.
Okay. Oh, I mean about the configuration. Sorry, ma'am. I'm
No,
just
no, no,
confused.
no, 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 it's okay, it's okay. Um, acha, what is the importance of gradient array? Why should we use gradient array in field?
Okay. Um. In case of gradient array, we need only a small length of cable uh, and between between this potential electrodes when compared to this total field method. And here, so it is. Yeah, so we can carry it upon a long area of long survey area.
Okay. And along with this, gradient array is least less affected by the background noise.
Ma'am,
And
the gradient is actually prone to more error due to this polarization.
but
Uh,
I have read in a one book that gradient array and Wiener array are least affected by the noise. The book written by Shalibahan sir actually.
okay.
And you may say one another thing that gradient array will give you a rectangular uh, area scanning, so it may used in profiling too.
Yeah.
So my next question is, mm, how can you identify porphyry copper deposit? Do you know about porphyry copper deposit?
Uh, yes, I have. It has a greater conductivity value. Mm.
Hmm. And it is associated with what deposit?
Sorry, ma'am. I don't know.
Actually, porphyry copper deposit is related to geothermal deposit. I mean, it is porphyry copper deposit is associated with meteoric water.
Ma'am,
Generally, yes.
can you repeat that? I didn't get that point.
What I want to say that porphyry copper deposit is related to high heat flow zone. Okay, basically it
Okay.
is associated with lava flow or magma flow.
Okay.
So you can delineate the zone using SP.
Okay. Okay.
Okay, and okay, mm, it's all from my side.
Okay. Thank you, ma'am.
Thank you.
Thank you, everyone. Okay, give one by one feedback. Pawan,
Yes. So Gauri,
Yes.
कॉन्फिडेंस हाँ अच्छा था आपका, कम्युनिकेशन भी अच्छी थी, बट ऐसा है कि कुछ एरिया में मतलब कि आपको आंसर रॉन्ग आता है फिर भी आप कॉन्फिडेंस के साथ में बोल रहे हैं, तो वहां पे थोड़ा ध्यान रखना, नहीं आता तो आप मना कर दो कि नहीं आता मुझे। ओके।
Okay, sir.
और अदरवाइज ऑल ओवर इंफॉर्मेशन वाइज भी बहुत शानदार था, और प्रेजेंटेशन ऑफ आंसर की बहुत अच्छी थी, ऑल द थिंग्स गुड।
Thank you, sir.
thank you, Pawan. Sumana,
या गौरी, मुझे तो आपका प्रेजेंटेशन बहुत सही लगा आज। और जो आपको नहीं आ रहा था, एटलीस्ट मेरे केस में तो आप सॉरी मैम ही बोल रहे थे, तो मुझे ठीक लगा काफी आज तो।
Thank you, ma'am.
आ गया।
yeah, she was really good. She has greater depth in knowledge.
Thank you, sir.
अमृत,
हाँ, मुझे भी ऐसा ही लगा कि गौरी, यू हैव इम्प्रूव्ड ए लॉट, एंड जो जो जगह पे नहीं जानते हो वो सही बोल रहे हो, ऐसा नहीं, ठीक है, कोई बात नहीं। और ये जो मतलब मुझे अच्छा ही लगा, ऐसा नहीं फील हुआ कि बहुत प्रॉब्लम हो रहा था। सो इट वाज गुड, वेरी गुड।
Thank you, sir.
yes, Gori, overall interaction with you, very nice. Communication, representation, both are very good. और सजेशन वही एक छोटा सा है कि कभी कभी ना आप यू आर एलोबरेटिंग मोर, अगर वहां से पूछा जा रहा है कि हाँ करो, देन इट इज बेटर टू एक्सप्लेन मोर।
Okay. Thank you, sir.
अदरवाइज सब अच्छा है।
Thank you, sir.
हाँ, एक मैं बताना चाह रहा था कि आप अभी ये जो पूछा था ना ग्रेडियंट मेथड का एडवांटेज, सो नॉइज एंड एरर में फर्क होता है। एक्चुअली नॉइज तो बैकग्राउंड नॉइज है जो हम केमिकल पोटेंशियल से, इलेक्ट्रोकेमिकल पोटेंशियल से लेते हैं, वो नॉइज जो है स्ट्रीमिंग पोटेंशियल की है। बट उसमें एरर आती है, कम्युलेटिव एरर उस मेथड में। सो जो पोलराइजेशन की वजह से है, उसे उसे करने के लिए हम वो मेथड यूज करते हैं, लीफ फ्लॉप मेथड। एंड जो बोल रही है सुमाना ने बोला है कि लेस अफेक्टेड बाय द
नॉइज,
नॉइज।
बैकग्राउंड नॉइज।
हाँ, तो वो एरर एरर तो हो, एरर का प्रॉब्लम तो है, बट नॉइज से ज्यादा इफेक्ट नहीं करता वो।
So we should always prefer this gradient method over the total, right?
हाँ, इसके एडवांटेज है तो डेफिनेटली।
Okay, thank you, sir.
Hello, Sumona, if you don't mind, I ask some question.
यस, प्लीज आस्क।
So my first question is that in field survey, which method we first use if we consider gravity, magnetic seismology, resistivity, and electromagnetic survey?
ओके, देन for any it depends on your what you are want to delineate. Okay, in
Okay.
case of base metal, basically we are using gravity magnetic firstly as reconnaissance survey, then we can use resistivity and max to max IP. For base metal this is enough, more than enough. Then we don't have to do any further exploration. But when you are going for seismic hydrocarbon exploration, then you have to do firstly gravity magnetic as reconnaissance survey to know the sedimentary basin depth. Then you have to go for seismic exploration, seismic reflection and refraction survey to get a good velocity structure of the subsurface. Then after getting the velocity structure, you have to go by well log.
Okay.
Okay.
Finally,
And yes, and in case of oil exploration, we generally do not use the SPIP and resistivity. Okay, because in case of oil, the resistivity method is done with the resistivity logging. But when we are going for any field survey, then sometimes, like in groundwater exploration, we may use resistivity method along with IP to discriminate between fresh water and saline water. And SP is now to some extent obsolete. We don't use SP that much presently in the field. But yeah, when it's a very conducting material, then we can use EM also, like for some ferrous ores, or for uh, yeah pyrite bodies, we can use EM method also. But what is the problem generated with EM na? EM is associated with greater amount of noise, so generally we are preferring aeromagnetic EM. Okay.
Aeromagnetic EM.
Sorry, aeromagnetic, sorry, I'm मतलब airborne EM,
Yeah.
aeromagnetic नॉय airborne EM.
So my second question is that if we arrange the all method in the depth of penetration, so which method is higher depth of penetration and after that lower and lower?
The highest depth of penetration is MT,
Okay.
because it almost go to core mantle boundary. Okay.
Okay.
And the lowest depth of penetration goes to GPR.
So we can say that gravity and magnetic also have more depth of penetration compared to the GPR.
Yes, gravity and magnetic have more depth of penetration compared to GPR.
If we compare to the seismology and resistivity, which have more depth of penetration?
Okay. Resistivity has less depth of penetration than seismic. In case of seismic, we may image the subsurface up to 8 to 10 kilometer, but in case of resistivity, it max to max 2 kilometer.
Okay. And in GPR, depth of penetration may be approximate, if you know.
In case of GPR, depth of penetration is maximum some few meter. If you get 1 kilometer, this is more than enough.
I
It
think
is
Venus
basically,
Lowry.
actually, GPR is used mainly in near surface structure observation. Yes.
Okay. In Lowry mentioned that almost 10 meter.
10 मीटर, इतने मतलब तो अगर बहुत हाई रेजोल्यूशन वाला इंस्ट्रूमेंट यूज करो तो शायद सम 100 मीटर तक जा सकता है, लेकिन उससे ज्यादा कभी नहीं जाएगा। जीपीआर का सबसे लोअर होता है।
So, Sumana, my third question is that how to use a GPR method in field survey?
How to use GPR method in field survey? Um, sorry, I have not revised the GPR yet, so I need
Oh,
some time to
okay.
explain.
MT method has greater depth than gravity, or gravity
Yes,
has greater depth.
empty method has greater depth.
Okay.
MT is a higher depth of penetration. Yeah, I think.
Yes, empty
Okay.
has higher depth of penetration.
So, Sumana,
What
my
is the
fourth.
order of gravity in according to depth? In gravity, how much depth can we go?
Gravity. Wait. I think in case of gravity, it's um, I'm not sure, but we don't. In case of gravity, basically, we don't use. I will read and I will say see and tell you after some time, because I am not exactly recall the figure. But highest depth of penetration is for MT.
Okay.
Okay. And Sumana, my fourth question is that how to measure, no, in a magnetic telluric method, we measure the component of electric and magnetic, right? How to
In
measure?
case In
In,
how to measure? I am not getting your question. Can you please
yeah,
repeat?
I can repeat. Yeah. In magnetotelluric method, we measure the component of electrical and magnetic component. Then we calculate the resistivity and depth of penetration.
Hmm.
So how to measure electrical magnetic component in field survey?
How to, you are asking about the instrumental part, right?
Yes, 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 yes.
Listen, as far I know that in case instrumentation, we are just measuring some few components of E and B. Like we can't measure the EZ component, as air earth is. Infinitely air earth surface is infinitely resistive. We are basically measuring the bx, by and bz, and then only ex and ey. We are just measuring the electric and magnetic field components in various directions.
Okay. So so in I think in field survey for measuring the component of electrical, we use the electrode, and for measuring the component of magnetic field, we use the I think coils mentioned in the I think law. It is right.
Yes, you have to use for electric, I don't know, but for magnetic you have to use coils, transmitter coils.
Yes, and for electrical, we use the component electrode.
But using electrodes, you can measure the voltage drop, na? How can you measuring the electric fields using
No,
electrodes?
the relation between the voltage and component of electrical field.
I am sure about the transmitter coil, but not sure about the electrical field.
I think it is mentioned in Lori that we are placing two electric dipoles perpendicular to each other, or something like that.
And also mention that the direction of the telluric current, then we can measure component of the electrical magnetic field during the telluric
Yes,
current.
can you please repeat?
Yeah,
Yes,
measuring
we are.
the
Hmm.
measuring the direction of telluric current, then the component of electrical magnetic also parallel to the telluric current. Then if we measure the telluric current component, so directly we measure the component of electrical magnetic field.
Yes.
And my first question is that once we collect the data, and what is the procedure
In case of what?
when we collect the data?
In case of which method? Every method has different processing sequence, right?
So can you give me some brief idea all the method?
Like in case of gravity, you have firstly you have to collect the data, then you have to apply all the corrections, then we have to do the regional residual separations. Okay.
Okay.
In case of magnetic, we have to collect the data first, and then we have to use only two corrections: IGRF correction and diurnal correction or drift correction. And then we have to process the data a lot, like we have to apply a filtering on it, then filtering, then you can apply continuation. For better symmetry, you can do reduction to pole or reduction to equator type of thing. And in seismic, there is a long chart of processing. I think I have told it some day before.
Okay.
Like you have to start from input file data set, then you have to demultiplex the data, then you have to apply the true amplitude recovery, then you have to edit the trace, then initial filtering, then deconvolution, then NMO, then migration, then after migration you can display the seismic section. And okay, and in case of resistivity, you don't have lots of processing sequence. You can directly collect the measure the voltage drop, and then you can predict the apparent resistivity of the ground. And in case of em, this is also same type of things. You just, in case of resistivity and ip, the main processing sequence is uh, drawing the pseudo sections. Okay.
And Sumana, my sixth question is that what is the porosity? I am not accurately know what is the precise definition of porosity.
Okay, the precise definition of porosity is the ratio of pore volume to the total volume of a rock.
So, what is the meaning of pore volume?
The meaning of pore volume is, listen, any rock is not fully compact. There are some pore spaces within it which may be filled by air, may be filled by hydrocarbon, that type of thing. So you are calculating the volume of the porous space by the total rock volume.
Okay. And tell me what is the advantage of the I think वो loss था ना वो porosity में और resistivity में relation था वो.
आर्चीज इक्वेशन बोल
Archie,
रहे हैं आप?
yes, Archie, yes.
जी जी, आर्ची इक्वेशन बेसिकली हम लोग यूज करते हैं। देखिए, मैं आपको बहुत ब्रीफली समझाऊँ तो हम लोग फॉर्मेशन क्या करते हैं, हम लोग आर्चिस इक्वेशन में हम लोग जो सैचुरेशन है, जो मेजरेबल देखिए, पोरोसिटी तो आप डायरेक्ट ऐसे मेजर नहीं कर सकते है ना, कि कितना अमाउंट ऑफ पोर वॉल्यूम है। आप तो ऐसे कोई रॉक को, अनलेस अनटिल यू आर डूइंग द कोडिंग, यू कांट से दैट यहाँ पे इतना अमाउंट ऑफ पोर वॉल्यूम है। तो व्हाट वी कैन डू इन भाया आर्चिस इक्वेशन, दैट हम लोग क्या कर रहे हैं यहाँ पे, हम लोग जो सैचुरेशन है, जो ऑयल सैचुरेशन या फिर वाटर सैचुरेशन जो हम लोग नाप सकते हैं, मेजर कर सकते हैं, उसको हम लोग अननोन क्वांटिटी पोरोसिटी से जोड़ रहे हैं। क्योंकि आपको लॉगिंग से रेजिस्टिविटी का वैल्यू भी पता चल रहा है, तो
Yes,
आप आइदर पोरोसिटी नाप सकते हैं, या फिर अगर आपको पोरोसिटी पता है भाया कोडिंग, तो आप वाटर सेचुरेशन नाप सकते हैं। लेकिन जनरली वाटर सेचुरेशन नोन ही होता है।
so Sumana,
मतलब हाँ
saturation का मतलब क्या है कि उसमें मतलब एक मैक्सिमम लिमिट होगी कोई वाटर की या ऑयल्स की रॉक्स के अंदर?
जी, मतलब जो पोर स्पेसेस है वो क्या हो सकता है, वो आइदर हाइड्रोकार्बन से फिल्ड होगा, या फिर वाटर से फिलअप होगा, या फिर एयर से फिल्ड होगा, राइट?
Yes.
तो कितना परसेंट ऑफ वाटर है, ये वाटर सेचुरेशन है। 1 माइनस वाटर सेचुरेशन इज हाइड्रोकार्बन सेचुरेशन। मतलब हाइड्रोकार्बन मतलब बस ऑयल नहीं होता, हम लोग गैस को भी हाइड्रोकार्बन ही मान लेते हैं।
Okay. Okay. And Sumana, my eighth question is that which array more appropriate for the archaeological department? If we consider Venner, dipole, and pole, something like that.
देखिए, अब कौन सा एरे ज्यादा इम्पोर्टेंट है, ये अब एक वर्ड में नहीं बोल सकते, ठीक है? आपका टारगेट क्या है, उसके बेसिस पे आप बोल सकते हैं कि मेरे लिए ये एरे ज्यादा इम्पोर्टेंट है। लाइक जो डाइपोल डाइपोल एरे है ना, वो हम लोग क्यों यूज करते हैं, इसका बहुत अच्छा लैटरल एक्सटेंट होता है एंड एक गुड रेजोल्यूशन होता है। तो हम लोग, जब हम लोगों को कोई वर्टिकल स्ट्रक्चर डिलिनेट करना होता है, लाइक मान लीजिए कोई वर्टिकल सील हुआ कि वर्टिकल डाइक हुआ, तो हम लोग डाइपोल डाइपोल एरे का यूज करते हैं, ठीक?
Okay.
एंड वेनर का क्या है, वेनर का ये है कि उसका वर्टिकल रेजोल्यूशन बहुत ज़्यादा है। तो मान लीजिए कोई हॉराइजेंटल स्ट्रक्चर हुआ, लाइक सेडिमेंट्री बेड्स, या फिर कोई, हाँ सेडिमेंट्री बेड्स ही मान लीजिए बस, या फिर सील्स, तो तब हम लोग वेनर एरे यूज करते हैं। एंड पोल अगर आपको बहुत दूर, मतलब हाईएस्ट डेप्थ ऑफ पेनिट्रेशन चाहिए, आपको बहुत डीप इन्वेस्टिगेशन करना है, लेकिन बहुत हाई रेजोल्यूशन नहीं चाहिए, देन यू विल गो फॉर पोल। And in case of groundwater survey, we are mostly using Schlumberger.
Okay. Mona, in induced polarization, we measure the induced polarization polarization voltage. So, what is the field procedure? How to measure?
इसका फील्ड प्रोसीडियर बिल्कुल रेजिस्टिविटी की तरह सेम ही है, ठीक। बस एक डिफरेंस है, रेजिस्टिविटी में हम लोग क्या कर रहे थे, हम लोग करंट ग्राउंड पे इंजेक्ट कर रहे थे, उसके बाद वोल्टेज नाप रहे थे। यहाँ पे इनिशियली हम लोग करंट ग्राउंड में इंजेक्ट करेंगे तो फिर क्या होगा, पोर फ्लूइड्स और रॉक में जो चार्जेस होंगे वो रीअरेंज्ड होंगे, ठीक।
Okay.
उसके बाद हम लोग करंट को ऑफ कर देंगे। अगर ऑफ कर दिए तो क्या होगा, जो रीअरेंज हुए थे वो फिर से अपना इक्विलिब्रियम कंडीशन पे, मतलब प्रीवियस कंडीशन पे पहुंचने की कोशिश करेंगे। उस टाइम हम लोग जो डीके कार्व होगा, मतलब एक वोल्टेज गेन करने के बाद वहाँ से जो डीके कर रहा है एक्सपोनेंशियली, हम लोग उसका नेचर नाप के बोल सकते हैं कि ये कंडक्टर है कि रेजिस्टर है। जैसे अगर कंडक्टर हुआ तो डीके बहुत बहुत टाइम से होगा, मतलब बहुत धीरे धीरे वो डीके करेगा, वोल्टेज को रिलीज करेगा। लेकिन अगर कंडक्टर हुआ तो रैपिड डीके हो जाएगा।
Okay. And Sumona,
हम्म
uh, electromagnetic survey also apply for profiling and sounding. True? I think lateral variation and vertical variation.
देखिए, इलेक्ट्रोमैग्नेटिक सर्वे लैटरल वेरिएशन, वर्टिकल वेरिएशन के लिए अब यूज़ होता है क्या, ये एग्जैक्ट मुझे नहीं पता, लेकिन इलेक्ट्रोमैग्नेटिक सर्वे बेसिकली मुझे जितना पता है कि डीप एंगल मेथड या फिर अपमैग मेथड, ये सब यूज़ होता है एग्जैक्ट पोजीशन ऑफ द ओर बॉडी जानने के लिए, एग्जैक्ट लोकेशन। जैसे डीप एंगल मेथड पे जहाँ पे वो प्रोफाइल जीरो को क्रॉस करेगा, डीप वर्सेस डिस्टेंस अगर आप प्लॉट करेंगे तो जहाँ पे डीप जीरो होगा फॉर अ वर्टिकल ट्रांसमीटर, उसके ही जस्ट नीचे मेरा कंडक्टर बॉडी लाई करेगा।
ऐसा मैंने पढ़ा था कि मतलब जो अपने पास जो कोयल्स थी, उनका ओरिएंटेशन अपन चेंज करेंगे ना तो उसका वेरिएशन भी चेंज होगा। लेटरल वेरिएशन होगा तो उसका ओरिएंटेशन एक डिफरेंट होगा। यदि वर्टिकल वेरिएशन अपन को मेजर करना है तो उसका ओरिएंटेशन डिफरेंट होगा इन फील्ड सर्वे।
हाँ तो इसका मतलब ये नहीं ना कि आप लैटर मतलब प्रो साउंडिंग या प्रोफाइलिंग कर रहे हैं, साउंडिंग या प्रोफाइलिंग तो ये दोनों टर्म्स हम लोग बस रेजिस्टिविटी सर्वे में ही यूज करते हैं। साउंडिंग मतलब होता है कि आप रेजिस्टिविटी का वेरिएशन नाप रहे हैं विथ डेप्थ, एंड प्रोफाइलिंग का मतलब होता है कि आप रेजिस्टिविटी का वेरिएशन नाप रहे हैं विथ ऑफसेट। बट इलेक्ट्रोमैग्नेटिक मेथड हम लोग साउंडिंग प्रोफाइलिंग करने के लिए जनरली यूज नहीं करते, हम लोग ओर बॉडी को लोकेट करने के लिए करते हैं।
हाँ, ये मैंने थोड़ा टर्मिनोलॉजी गलत यूज की है, बट वहां पे का वेरिएशन अपन देख सकते हैं, वर्टिकल और लेटरल वेरिएशन देख सकते हैं।
जी, आप कॉन्डक्टिविटी का लैटरल या वर्टिकल वेरिएशन चेक कर ही सकते हैं ये मेथड से, बट इसको आप प्रोफाइलिंग और साउंडिंग का नाम नहीं दे सकते।
Yes, yes. And Sumana, in we measure the quadrature component and I think phase component, quadrature component. What is the importance for quadrature component in electromagnetic induction?
देखिए, अगर ये जो इन दोनों का रेशियो क्या होता है, 10:5 होता है, ठीक है।
Yes.
तो फाई के वैल्यू से आपको पता चलेगा कि अंदर ये है, मतलब कंडक्टर है कि रजिस्टर है, बस दैट्स इट, इतना ही इसका एप्लीकेशन है कि आपको जो फेज एंगल होगा ना फाई, उससे पता चलेगा कि अंदर कंडक्टर है या फिर रजिस्टर है।
Okay, okay. Any range for phi less greater than this angle, तो any कुछ range given है?
जी, इसका एक रेंज है। अगर देखिए, फॉर ए गुड कंडक्टर फाई ऑलवेज अप्रोचेस टू π/2, एंड फॉर ए बैड कंडक्टर फाई ऑलमोस्ट अप्रोचेस टू 0।
Okay. And Sumana, we electromagnetic induction survey, we measure the secondary voltage and primary voltage ratio, right?
Mm, not always ratio. You are basically measuring the secondary field at the transmitter coil. Okay, हाँ डन बोलिए.
वहां पे नेगेटिव एनोमली मिलती है अपन को जब कोई कंडक्टर है अपने दोनों कॉइल्स के बीच में होता है मिड पॉइंट पे, तो वहां पे नेगेटिव, व्हाई वी आर ऑप्टिंग नेगेटिव एनोमली?
देखिए हर वक्त नेगेटिव ही एनोमली मिलेगा ऐसा तो ज़रूरत नहीं है ना. अब तो टूरम में तो कंडक्टर के लिए हाईएस्ट पॉजिटिव एनोमली भी मिलता है. ये तो डिपेंड करता है. देखिए एनोमली का वैल्यू सेकेंड फील्ड का वैल्यू किस पे डिपेंड करेगा. आप एक एच एस दे रहे, मतलब आप बस एक एच पी क्रिएट कर रहे थे. तो एच पी जब आप क्रिएट कर रहे हैं तो वो एच पी ग्राउंड के थ्रू भी पास हो रहा है एंड वो आपका मतलब क्या बोले ऊपर मतलब सरफेस के ऊपर से भी पास हो रहा है. अगर नीचे कोई भी कंडक्टर बॉडी नहीं होगा तो फिर ऊपर वाला जो ये रेस्पॉन्स होगा मतलब ए आर आर सरफेस में जो रेस्पॉन्स होगा और ग्राउंड के भाया ग्राउंड जो रेस्पॉन्स होंगे दोनों ही रेस्पॉन्स सेम होंगे. द ओनली डिफरेंस इज ग्राउंड का एम्पलीट्यूड थोड़ा कम होगा. ठीक. लेकिन अगर नीचे कोई भी कंडक्टर बॉडी होगा तो फिर क्या होगा, वहां पे एक वो प्राइमरी इलेक्ट्रिक फील्ड के कारण एक एडी करंट फ्लो करेगा और एडी करंट के फ्लो के कारण एक अलग सा सेकेंडरी मैग्नेटिक फील्ड जनरेटेड होगा नीचे का वो प्रेजेंस ऑफ कंडक्टर के कारण. तो आपका जो ट्रांसमीटर में जो आप नेट मैग्नेटिक फील्ड मेजर करेंगे उसका वैल्यू डिफरेंट हो जाएगा कंपेयर टू द ए आर आर टी इंटरफेस. तो इसका एम्पलीट्यूड डिपेंड करेगा, हर वक्त नेगेटिव ही होगा ऐसे ज़रूरत नहीं है.
थैंक यू सुमरा.
थैंक यू.
Sumana,
Yes.
I have one question that for the groundwater exploration, which combination of methods should we use?
For the groundwater exploration, generally we used combination of resistivity and IP. By using the resistor, we may use seismic, but don't prefer it because seismic is too costly for groundwater. So basically, what we are doing, firstly, we are measuring the ground resistivity, and if we get the and we all know that the resistivity of ground is something sorry, the resistivity of groundwater is like for fresh water it varies from 10 to 100 ohm meter and for saline water it's less than 10 ohm meter. So by using resistivity method you can uh, by using resistivity method you can firstly identify the potential zone and then only you can use IP method to discriminate between the saline water and fresh water.
Thank you. अच्छा एक क्वेश्चन
Welcome.
हो रहा है, among the all methods, which
हम्म,
method is most economic?
देखिए सबसे सस्ता होता है ग्रेविटी एंड मैग्नेटिक, इसीलिए हम लोग इसको रिकॉग्निशन सर्वे में यूज कर लेते हैं. लेकिन रेजिस्टिविटी भी बहुत चीपर ही होता है. बट ईएम काफ़ी कॉस्टली होता है. ईएम काफ़ी कॉस्टली होता है, फिर साइज्मिक लॉगिंग ये सब काफ़ी कॉस्टली होता है.
Okay, thank you.
चीपर चीपर आपको अगर बोलना है तो आप ग्रेविटी मैग्नेटिक कर सकते हैं. Gravity, magnetic resistivity. These are cheapest methods.
So guys, should we end session or continue?
हाँ, तुम तो शायद अभी बाकी हो, और कोई है सेशन के लिए, या फिर हो गया है
Yes,
तुम्हारा?
Vidyut is also remaining.
अच्छा,
Okay, already session is going for more than 140 minutes.
Yes. So I
1 hour.
think कल करते हैं. I think it's better.
Hello.